Why are rubies red, sapphires blue, and why does that color even matter? Gem colors are one of those places where physics and chemistry and a little magic all come together. First, let's talk about why gems even have color. It all has to do with how they absorb and transmit light. Visible light is made up of all the colors of the rainbow. When light hits a gem, some's absorbed, some's transmitted, and some's reflected. And it's the reflected light that makes the gem sparkle and gives it its characteristic color. But why does a gem absorb certain colors and not others? That's determined by the gem's chemical composition. Different atoms and elements will absorb different wavelengths of light. For example, emerald gets its green color because it contains either chromium or vanadium. These elements absorb red and yellow wavelengths of light and reflect green. Ruby, on the other hand, gets its deep red color from chromium. In this case, the gem actually reflects only one color, while absorbing all the others. Next, there's the crystal structure, also called the lattice. The atoms in a gem are always arranged in repeating patterns, and this structure influences how light passes through, bends or refracts, or even splits as it moves through the gem. This property is called pleochroism, and is exhibited by gems like tanzanite, which looks blue when viewed from one direction and yellowish-brown when viewed from another. You can actually use pleochroism to help identify a gem's crystal structure. But wait, there's more. Sometimes the most important factor affecting a gem's color isn't even part of its chemical formula. In fact, trace elements and impurities can drastically change a gem's appearance. Take corundum, which is pure aluminum oxide. If you add even the tiniest amount of chromium to the mix, you get ruby red. Add iron plus titanium, you get sapphire blue. On the other hand, if you have pure quartz, you get a clear, colorless stone. But if you introduce iron into the mix, you might end up with amethyst, the purple variety of quartz. Or if you heat clear quartz, you might get citrine, the yellow variety. Or if quartz gets exposed to natural radiation, you get smoky quartz. So sometimes a little imperfection is just what a gem needs to get its color. Speaking of imperfections, sometimes the flaws or defects in a crystal lattice can affect the gem's color too. Natural or artificial radiation can alter how light interacts with the gem, and this often results in a totally different look. For example, both smoky quartz and blue topaz owe their colors to natural radiation. Finally, there are inclusions, which are tiny trapped minerals, liquids, or even gases inside a gem. Inclusions are often considered flaws, but they can also make a gem more colorful. For example, in certain lighting, you might see a six-rayed star inside a sapphire, a phenomenon called asterism. Or you might see a cat's eye effect in chrysoberyl, also known as chatoyancy. These effects are caused by tiny needle-like inclusions inside the gem. Now let's take a look at a few special optical effects that gems can exhibit. Opal is famous for its beautiful color play, which is caused by the diffraction of light as it passes through spheres of silica. The spheres are different sizes and are randomly arranged, which causes the light to separate into its different wavelengths, creating those gorgeous flashes of color. Labradorite and moonstone exhibit another optical effect called iridescence. Thin films of different materials cause light to interfere with each other, creating those beautiful flashes of color. Alexandrite is known for its dramatic color change, appearing red under incandescent light and green during the day. This unusual behavior is caused by how it absorbs light, which changes depending on the wavelength. At rest, the gem absorbs yellow, red and blue light, reflecting green. But once exposed to UV light, the atoms become excited and start to fluoresce, emitting longer wavelengths of light, which appear more red. Alright, let's shift gears a bit and talk about the metaphysical view of gem colors. Many cultures and traditions believe that a gem's color reflects its energy vibration or the energy of the planet it is associated with. Red gems such as ruby and garnet are said to be powerful and vital, connecting us to our root chakra. They're believed to bring courage, strength, and vitality. Green gems such as emerald and jade are associated with nature, healing, and the heart chakra. They promote growth, harmony, and balance. Blue gems such as sapphire and lapis lazuli are said to bring wisdom, communication, and tranquility. They connect us to the throat chakra, encouraging self-expression. And violet gems such as amethyst are associated with spirituality, intuition, and the crown chakra. They enhance our connection to the divine and promote spiritual awareness. In summary, the color of a gem is determined by several factors, including chemical impurities, crystal structure, and how the gem interacts with light. Even tiny amounts of certain metals can completely change a gem's appearance. And sometimes the imperfections caused by radiation or inclusions can result in some of the most beautiful colored gems. So next time you look at a colorful gemstone, remember that its color is more than just an aesthetic feature. It's a result of a complex interplay of physics, chemistry, and a little bit of magic. If you enjoyed this video, like and subscribe to see more.